What if the smartest decision in an industry's history is also the one that quietly destroys it? That's not a hypothetical. That's exactly what happened to the largest passenger aircraft ever built, and the moment it went wrong isn't the moment anyone thinks it was. Around the world, airports did something they had never done for any other aircraft in history. Taxiways widened. That wasn't enough. Boarding bridges had to be torn out and redesigned from nothing. That still wasn't enough. Even the concrete beneath the wheels had to be rebuilt just to survive what was coming. Not for a new airline. Not for a fleet. For one plane. The Airbus A380. Airbus poured nearly $25 billion into it, and surprisingly, the aircraft itself wasn't the biggest reason that number got so large. We'll come back to that. Airlines ordered it before it existed. Passengers talked about flying it years before they could. And then, quietly, Airbus stopped building it. Here's what nobody tells you. There isn't just one mystery in this story. There are three, and for years, nobody realized they were the same mystery wearing different disguises. Why did this aircraft need 4 engines, when everything else in aviation was moving to 2? Why did airports gamble billions rebuilding themselves around a plane that hadn't proven anything yet? And why did an aircraft that pilots loved, passengers requested by name, and engineers still call a masterpiece, simply disappear from production? 3 questions. 3 separate investigations. By the end, you'll see they were never separate at all. The easy answer to all of it gets repeated everywhere. It was too big. Here's the uncomfortable part. That's true. And it's also false. The Airbus A380 was too big. And the Airbus A380 was never too big. Both of those statements are correct, and figuring out how that's possible is the whole story. To get there, we start with the assumption that looked, at the time, impossible to argue with. For most of aviation history, one formula never failed: more passengers meant bigger airplanes. Bigger airplanes meant more profit. Every generation got larger than the one before it. So in the 1990s, as passenger numbers surged, Airbus wasn't asking whether aviation would keep growing. They were asking something sharper. What happens when there's no room left to grow on the ground? Runways take years to build. New airports take decades. Airbus looked at that bottleneck and reached a conclusion that felt almost undeniable. If airports couldn't get bigger, airplanes would have to. One giant aircraft, replacing 2 smaller ones. Same runway slot, twice the passengers. On paper, it wasn't just a good idea. It was the obvious one. The prediction became so convincing that entire airports began rebuilding years before this aircraft ever carried its first passenger. That's not something an industry does for a hunch. That's something an industry does when it believes the future has already arrived. Which is exactly what makes what happened next so strange. Because while Airbus was solving the problem in front of them, a second problem was already dissolving underneath them, and neither Airbus, nor the airport spending billions on faith, could see it yet. We'll come back to that. First, mystery number 2 starts here, because you can't understand why airports gambled everything on this aircraft until you understand exactly what they were gambling on. Calling the Airbus A380 the largest passenger aircraft ever built is technically accurate. It's useless for understanding what standing next to one actually feels like. Wheel it up next to a football pitch, and its fuselage stretches almost goal line to goal line. Spread its wings, and one tip nearly reaches one end of the pitch while the other reaches toward the far end. Go inside. 2 full-length decks, stacked one on top of the other, running almost the entire length of the aircraft. Enough floor space to fit 3 tennis courts under one roof. At full capacity, it carries 853 people. Not a full flight. A small town, leaving the ground together. Fully loaded, it's carrying more than just people, and every extra pound of that load is about to become a problem somebody has to solve. Yet seconds after this thing starts moving, it's in the air. Not violently. Passengers described the takeoff as strangely calm, closer to a train leaving a station than the largest aircraft on Earth lifting itself off the ground. That calm didn't happen by accident. It happened because engineers were cornered into it. Every solution created another problem. Airbus solved that one. Then another appeared. Then another. More weight demanded more lift. More lift meant bigger wings. Bigger wings needed more thrust to move them at all. Eventually, Every calculation cornered the engineers into one unavoidable decision. 4 engines. Power wasn't the real reason. Ironically, engineers had already solved the power problem years earlier, on a completely different aircraft. We'll come back to that too. That's one mystery already sitting unanswered. It won't be the last. Here's the twist: the size was never the ambition. It was the symptom. Long before a single piece of this airframe existed, Airbus was convinced aviation was heading toward a crisis. Not fuel. Not technology. Space. The bottleneck was never the airplanes. It was the ground beneath them. Millions of new passengers were arriving every year, and airports had nowhere near enough room to hold them. So this wasn't a machine built to impress anyone. It was a machine built to make a problem disappear that nobody else could solve. That's the only reason what happened next makes sense, and it answers mystery number 2. The prediction was so convincing that governments, airport planners, airlines, and investors all moved together at the same time on the same bet. Taxiways widened. That wasn't enough. Boarding bridges had to be torn out and rebuilt from nothing, because nothing existing could serve 2 full decks at once. That still wasn't enough. Fully loaded for takeoff, this aircraft weighs close to 575 tons, roughly the same as 1,000 elephants standing shoulder to shoulder, and that weight, riding on 22 wheels, meant even the concrete beneath it had to be rebuilt just to survive it. Hold on to that image. Those elephants are going to matter again later, in a way that has nothing to do with runways. Even hangars built for the previous generation of aircraft were suddenly too small. Ironically, many of those same airports would eventually discover they had prepared for a future that never fully arrived. For a moment, though, everything was unfolding exactly as Airbus had drawn it up. Right now, 3 things are hanging over this story unanswered. The real reason for 4 engines, the real reason the $25 billion bill got as large as it did, and the real reason those elephants are going to come back. All 3 trace to the same place, and that place isn't the aircraft at all. It's a prediction Airbus made, one so confident it convinced an entire industry to move before the evidence existed. Except somewhere else, far from the factory floor, far from the airports pouring concrete, a second revolution had already started, quietly, without a headline. And this is where mystery number 1, the 4 engines, and mystery number 3, why the plane disappeared, start to become the same question. It wasn't happening in the wings. It was happening inside the engines of a completely different kind of aircraft. When Airbus committed to building the A380, they were watching Boeing. They should have been watching time. Because while thousands of engineers raced to finish an aircraft laced with enough wiring to stretch farther than the distance between 2 major cities, a different problem was being solved somewhere else entirely. Not how do we build bigger planes, but how do we make small planes fly farther. At first, the gains looked almost too small to matter. A little more efficient, a little lighter, a little quieter. Year after year, those improvements stacked, until they stopped being small. For decades, crossing an ocean meant routing through a major hub, London, Dubai, Singapore, Frankfurt, because there was no other option. That was exactly the world Airbus had designed the A380 for. Then the ground shifted. Engines didn't just get more powerful. They got efficient enough that twin-engine aircraft could cross oceans that used to demand 3 or 4 engines. Remember that unanswered question from part 2, why power wasn't the real reason Airbus chose 4 engines. Here's the payoff. The rule that justified 4 engines wasn't really about the A380 at all. It was about an era where 2 engines couldn't be trusted over open ocean. That era had already quietly ended by the time the A380 entered service. Airbus had built the answer to a question the rest of the industry had already stopped asking. This is where the 2 competing truths from the opening finally make sense together. The A380 was too big. True, the aircraft only made financial sense when it was nearly full, and filling 500-plus seats, every flight, on every route, became harder as travel patterns shifted toward direct city-to-city flights instead of hub-to-hub megaflights. The A380 was never too big. Also true, nothing about the aircraft's engineering, comfort, or safety ever failed. It remained one of the most loved aircraft ever built, right up until the last one rolled off the line. Both statements survive because they're not actually about the same thing. One is about the machine. The other is about the world the machine was flying into. And here's where the elephants come back. Earlier, that 1,000-elephant weight explained why runways needed reinforcing. Now it explains something else entirely, why every empty seat on an underfilled A380 became so expensive. A giant aircraft only pays for itself when it's nearly full. An A380 carrying 550 people is a spectacle. The same A380 carrying 250 is a financial wound, for engines to fuel, for million components to maintain, 1,000 gallons of paint to reapply, regardless of how many seats are empty. Smaller twin-engine jets gave airlines something the giant never could offer, the freedom to fly often instead of flying full. Remember that $25 billion investment from the opening? Most people assume the aircraft itself is what made it so expensive. In reality, a huge share of that cost was building infrastructure for a version of the future that airlines would only partially need. The future Airbus predicted wasn't wrong. It just arrived in a different shape than anyone expected. So here's what was actually happening underneath every part of this story. Why did the A380 need 4 engines? Because it was built to answer a question the industry was about to stop asking. Why did airports spend billions preparing for it? Because the prediction behind it was one of the most convincing in aviation history. Why did an aircraft everyone loved simply disappear? Because loving a machine and needing it are two different things, and only one of them keeps a production line running. 3 mysteries. One answer, running underneath all of it the entire time. Airbus wasn't wrong. The future changed. And that's the part almost nobody talks about when they explain why the world's largest passenger aircraft stopped being built. It's easy to say an engineering team got it wrong. It's much harder to admit that the hardest problem in aviation was never building the machine. It was predicting the world that machine would have to fly into.